Turn this into a multi-port sampler. 1, 2 inputs, multiple inputs, multiple test ports. Yesterday I had so much shit going on I couldn't do nothing. Start to do something and something else bad freaking stop or drama or some bullshit. So I got so much bullshit going on in my life right now, it's stupid. Alright, this is my loader. So dropping. So I can do the 0.1. That'll be the shunt. That'll be 0.1. So we need to make a 0.1. So we're going to find the 0.1 decoupling. Can puff. So we got the shunt and a DC blocking cap I'm going to use. That way we don't get any unwanted DC. Now I'm just trying to lay everything out. The way I want it. So that can go down by there. That's fine. Turn this 180 degrees so I can get this. $180. There we go. Now it lined right up. Perfect. Now we can stick. Which one's this? I got one over here too. Couple of decouplers. This is okay. These 0.1. All right, there they are. Those are the same caps. All right. Shorten it just a little. I obviously need to spin it some more. All right. Now, it's kind of tricky because when I put my hands in here, everything goes dark. You can't see nothing. Push that cap back there. And it. It's going to fight me is what it's going to do, but I always do. We just can't see it. There we go. Let's start with getting the cat don't have to tie there. I'm gonna go get my vise real quick, guys. Awkward situation here, man. Oh man, I can't get this. That ain't gonna work. Get this where I can work it. And there's nothing I can really put underneath it because as soon as I do, I'm gonna be moving it. Let's just gonna have to just work with it at a flopped out angle. There's no way with all the BNC sticking out of it everywhere, there's no way for me to really set it where I can use it. We're just gonna have to kind of work with what we got. Now I think I'm just going to straighten that part out. Let it lay. I think I'll cut a little bit off the tip. Box is getting so tight, guys. Can't hardly work in the damn thing. Perfect. Perfect. That'll let me bond them two together real nicely.
gummies?
Do what?
You want to leave you a gummy?
All right. That works. Do what? Now we gotta put a resistor. I'll find it in a minute. There's a big ass 2.7K resistor floating around here somewhere.
I'll see you sooner.
Alright, yeah. There it is. I love you too. What? Now this 2.7 K ohm resistor is going to set in the middle between the inductor or the so we'll be able to slide this way back. It's a lot of work, guys, to do this stuff, and it's real tedious. Hey, there we go. That's how I did it yesterday. I just remembered. All right. So we're going to straighten our legs. So I went with a piece of coax, 50 ohm straight pass through. And I'm building decoupling so that there's no DC getting on the scope. So that's about perfect. Once we cut this short, don't really need to cut it much shorter, do we? Now we'll take a pair of needle nose and we'll scratch. Get my scissors out. Turn that stuff on and warm it up. Let that stuff be warming up. Alright. Now I'll scratch. Let's use these. We can get in there a little closer. All right. Got a good mag 10 there. Worked out real good. Now where's my resist the AC? Alright. I think I'll make an eyelet for the capacitor leg for the resistor to set in. Actually, I think that's going to bond and solder real. There's the resistor. All right. Here's what it looks like so far, guys. This one. What the hell did I do that for? Alright. Now I'm going to turn the light off. There we go. Alright. So now, okay. Pretty good box. It's pretty well built now, so I'm thinking about I'm going to tighten this stuff down. This is an air gap sampler in the middle, if you guys don't know what that is. And then you have a you stupid motherfucker. I have to hold my phone down because it wants to be a prick. Alright. Now you won't be able to turn. Pretty cool build. Oh my god, man. Pretty clean build. This one turned out pretty clean. Just turning the DNC. Everything's twisted. That is so fucking dumb. It's fucking spinning. Oh, you stupid motherfucker, man. I fucking swear, dude. You're about to piss me off. Sit there and spin. Fuck the entire design up. Because you want to spin and move. I'm not spinning and fucking moving shit. It's tricky to get in here and tighten these screws, but it's got to be done. And then when your hands are big as fucking Neanderthal fucking. There we go. We got a little bit. This motherfucker. That's a good sign. When did that start? One. Well, that's a whole lot better. Forward power. Forward with the set. Oh yeah. But we can't have the DC this Are you fucking serious? So is that blocking my signal that much? And this is why it's a pain in the ass. Trying to get all this shit right. I'm so fucking done with this shit. So that cat. Never gonna let her go. So we'll move this. Okay, because that's isolating. So we got a real good pass through. Our SWRs are great now. So we're gonna move this cap. See what our pass through is going directly. I'm just gonna spend all day till I get this exactly how I want it. Alright, so check this real quick. When did this happen, though? Alright, 2 months ago, we want to go forward set. Okay, 1.2, 1.1. 1.1. See what we got here. Forward. Set. 1.1. Alright. So when we put the pass-through box on, this box, let's do it in reverse here. Don't matter. I'll rebuild it 100 million times till I get it exactly the way I want it. I don't care if it takes a month. I just want to see the pass through. Alright, so we're going to check it now with the circuit put in. We're going to go to set, which it goes right to set. And then we're going to go to read. And it goes forward. Set. I don't even move. So the input coming back. And here. Okay. This is what we're going to do. Alright. We're getting real close. Let me see what the radio says. It's coming back to the radio. One point. 1.0 at the radio. So on this input, I think I can put a microcapacitor to ground. Okay, we're getting real damn close. Remind me to turn that light off too whenever I go to test this finally. Man, this thing's, I'm trying to get this thing just right, is deeming kind of difficult. So let's take the cap off. That's going to be hard because I fucking soldered the cap good. Now we'll grab a hold of the cap and try to get it off nicely. Just like that. Set that down. And we'll go right back with our shunt. I know, it's not ideal, I know. Back to the shunt. Now, now we'll try to join this into the circuit. Oh, we haven't soldered it all. So I can do this shit. Are you fucking serious, guys? Alright, let's see what this, how this response is. That's tight. Let's see what this does. If it don't work right, we'll tear it all the way apart. Start all over again. Are you fucking kidding me? Okay, we're getting bias DC. Bias DC. Aha! Ta-da! And there it is. Damn. So I didn't want that resistor. 1, 2, 3, 4, 5. There it is. There it is. Now let's look at our reflex. Look at that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Beautiful. 50 dB. Beautiful. All right, there it is. So now 1, 2. Let's check this. Fuck yeah. All right, set. Read 1.1. Let's do this one. Forward. Set. Don't even move. 1, 2, 1, 2, 1, 2. There it is, folks. Took me 2 hours for the last 3 days to get this thing right. All right. Now, we'll clean it all up. All right, it's working wonderful. It didn't want that resistor on that inductor that was causing it to all right, so now I'm just gonna shorten it all, clean it up. Now that it's working good, I'm gonna put a new BNC connector in it because I've wore that one out. Good deal. Now we got it, the design about right. That's what I want. And I'll double jam nut this sumbitch now that I've got it, the design right. Signal's super, super clean now. All right, let's put us another. Man, these are really high dollar BNC tips. They're really good ones. Try to put a You want it tight. Now. Perfect. Perfect. So I'm just clocking it where it'll work best for what I'm doing here. And not turn away from me. And it's still gonna fucking do it. You stupid motherfucker, man. Great. Now that gun's dead. Like, fucking seriously, people? Fucking walk. I go through doing this. These fucking things. Tighten this son of a bitch now so it quits doing that gun shit on me. See? And that's what it keeps doing. There we go. There we go. I was going to try to get another nut on it, but that's pretty clean little build. And I'll put that shunt down in there. Clean. Okay. We'll solder that and affect this over for a minute. Think about putting a mica. So I'm made a physical connection here. Need a decoupler, 0.1 decoupling capacitor, 101. We need a 102. We're going to put a couple of 102s. We'll do that. Let's get this. The reason I do all this shit and I show everything I do is because if you guys at home are trying to build your own stuff, you can look at my mistakes, look at the things that I've done to learn what not to do. Obviously. Well, that took real nice. Now we'll lay the shunt, and that's what keeps everything tuned. Now our reloading some. Yep. Sure is. One, two, three, four, five. 1, 2, 3, 4, 5. One, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hello, hello. Oh, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hello, 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 hello. Alright, so it's working really good. See that slight bit of DC? See how it's loading slightly? So we're going to go to DC Pro. 10, next page. offset. And there's an offset. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, guys, we're actually getting somewhere. Very clean scope. Very clean spectrum analyzer. Now I'm going to check and see if any of the components in the RF tap or have any crazy characteristics to them if I touch them. Alright, so we got decent isolation. We got a good, touch that. Okay, that slightly goes down. So we're basically right there now, guys. I'm going to play with it some more, like a couple of coupling capacitors. There's a slight bit of DC. So I'm actually thinking about turning that toroid loose, putting a DC cap. We may not need to at this point, it's pretty damn close. See, now you're positive loading. So we're going to get offset. It's going to do one thing that's scary. So what that's doing, so that's got a cap, an issue. I'm going to have to say about fixing that too. That's the reason why we're not using that tap. Because I think it's got a coupling cap bad. That's why it's charging DC on my lights. When I try to use my oscilloscope port, I probably ought to look at that, but now that we got this one, and that's with even with we want to go down to 0, 0. And that's with it's making sure that the LED ain't causing me problems. Alright. So we're gonna run this. Beautiful. So I got a really phenomenal scope signal with my RF tap. I've got a oh 1.0 on the radio. 1.0 here, and one, two, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Forward power. Forward. Watts. 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right. Well, that's getting a lot more hopeful. And if you look right there, there's no offset. Look at that. What changed? What changed? Our offset went to 0. Hell yeah. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. What did I touch? Well, that's perfect. Offset 0. Scope line setting at 0. Oh, check our input. You gotta be kidding me. I'll be down. I mean, it's working absolutely perfect, guys. Audio, 1, 2, 3, 4, 5. That's the sampler we just made. I can't believe I don't have to put a DC cap in it. But look how good, man. And this is what we just built. I built 3 of them in the last 2 days. I'm just trying to. This is my dual sampler. I built from scratch. If you look underneath the bottom of it, it's all open and exposed, but we're just testing it. But look at this. Look how accurate. So we're going to go take you all to first we're going to show you forward. So there's your 10 watts. 10 watts. 100 watt scale. 10 watts. 50 watt scale. Okay. Now we're going to go to forward set for reflect. That means, so we're going to key. We're going to set the reflect to that cell. To that set. It's already there. Now we're just going to go to read SWR. There's your 1.1. Now here's what, now check this out. Full power, or not full power, but we're going to sweep 1.1 out of our radio. 1.1 out of our monitor. And this is where it gets pretty interesting. We're going to go forward. And we're going to set the SWR on this meter. Okay, we need to back up just a roach. See the set. We need to go deep into it. A little bit more. I only got one free hand, so I got to do it in bump sections like this. And what's that need? Just a smidge more. Set. All right, now we're going to flip to reflect. Now this is the exact reflected power directly at the network. 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. So now with my RF sampler network, we've got our network matched to the termination impedance. We have the line impedance back to the monitor. All the way back to the radio, reading the exact same reflect. 1 1. 1 1 at the radio. Actually, it's 1 0 at the radio. And 1 0 at the load. If you look over at the scope, there's no DC, no bias, nothing getting into anything. I'll go down to channel 20 so you can actually see the tracking system on the FFTs. So there's that. Of course, we're going to come down. We're getting it now, guys. I'm just kind of seeing. Now we'll run this. I'm doing it all in front of you. I'm going to key with my thighs. And we're going to run. So there's that. There. Unkey it. And I'll put this. So there's our two spectrums. Look how clean. Top. Y 2 3 4 5. 1 2 3 4 5. Input reflect. And let's go forward power. So now we're going to key it on a 100 watt scale. Average only. We're going to key it on the 10 watt scale. There you go. Key it on a 100-watt scale. It's pretty cool, isn't it? Now we'll go to the internal dummy load, which will just bypass all this. As you can see, now the scope won't read. And check this out. So we're on the internal dummy load. We're going to go to set RF, or set reflect, set RF. Now we're going to go to read the SWR. 1111. 11111. There is no SWR. Now that's the internal load. Let me go to 10-watt scale. I'm gonna turn my power down on my phone or on my. I'm gonna go to 10-watt scale. Absolutely. That's incredible. It took me a while to get this like this. God. When you do, it makes things nice. So we're going to go 4 average only. So there's 7 average keyed. 7 average keyed. Let me see if we can't demonstrate something like that over here. To demonstrate that, I've got to. Oh, look how accurate, man. My God. Look how accurate. So this is internal load, meaning it's not going to the meter. Internal load, average power, 10-watt scale. What's it setting on? 7. Now we're going to flip it external, meaning it's going to the bird dummy load to the external and read this output power. We're on a 10-watt scale. So there's 1, 2, 3, 4, 5, 6, 7. 7 and a tad bit of change. Come over here. Go back to internal. 7 and a tad bit of change. Go to external. And we're still going to read this meter. 7 and a tad bit of change. So no matter what path, which line, what way you do it, you're getting the exact same reading no matter which way you do it. That means we have absolute no reactance, no impedance bump. We've got this thing right where we want it now. It took 2 days to get it there to where we're not getting a massive DC bias to the scope when we hook it up. It's a beautiful thing, man. It's a beautiful thing. I really don't think that I'm going to need to do anything more. I mean, it's just working. Looks pretty good, too. All right. Get you guys back over here and plug you all back in. I find that kind of weird. I really find that kind of weird. Because now, no matter what I do, there's no DC on my scope. It's literally doing exactly what it's supposed to be doing. Nothing goofy. Hallelujah. Let's take it back apart and put the bottom covers on it. I don't think there's any necessary needs to do any decoupling. I don't think I need to worry about the line. I mean, shit, my SWRs are perfect. My pass-through's perfect. Let's go to full power. Pretty cool. So if I don't even go into that, let's go internal. Is it still up that high? Hell yeah. That is incredibly awesome. That's really awesome, guys. It's working really freaking good. I can't believe how good it's working. That's pretty awesome. Especially with all the trouble I've been having with everything going on. I'm pretty stoked. No DC on my scope. It's doing exactly what it's supposed to be doing. Good. Here's the little circuit that I'm running. It's been modified a bunch of times. I wanted to get more surface to the shunt system, and then I wanted to get a little bit more shielding from connection point slight. And if you look, I referenced the shield immediately at the terminating ends of the pass-through coax. On the other one, I didn't have that, and it was causing a little bit of of a signal stray. This circuit here is what sniffs and feeds the spectrum, and then this is a shunt to 50 ohms to put everything to reference. I was going to decouple, put some decoupling caps, but I don't think it's going to be necessary. If I get any more, I'm going to put it back together. If I start getting anything weird, then we will. But my system seems to be running really nice right now. So while it's working good, we're going to put it back together. And then we'll do some tests. It seems to be working pretty good now. I swore we had a different setup yesterday, but whatever. I think it was a star. Yep. All right, I'm going to hook it back up. And we're going to see what kind of response we get. Things look really good right now. Clean these up. All right. Okay. Finally, all the hours of stress. Nope, it don't go that way. No, it don't go that way. Oh, it's even more cleaner now. Because it's got the damn box on it, the shield. Hell yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's good. Oh, that's good. Man, I can't believe how fucking accurate that is. Fucking awesome. Beautiful. Man, that's awesome, guys. I finally achieved something. Finally achieved something the way I wanted it. That's great. That worked out really good. I was so stressed out yesterday arguing with my wife. That's gonna work. Check our SWRs. It's 1.0. That's done. Done! Good deal. That makes me feel a little better. So, I didn't like this. Too much resistance. And then the body and the resistor style was causing some funny characteristics I didn't like. So, and I'm not up at a 100 watt continuous signal. So at low power, it was causing things I didn't want. And then with the original circuit, I was getting that will work, I do believe. That is going to work. Let's put this on. Really impressed with how clean the scope is now. That's awesome. We ain't getting any that weird shit because of that toroid. Just lets the AC pass. You see what I'm saying? It works. Though Stockton's circuit works good. I'm gonna go into my big flat side. Hey, hello. Hey, hello, DX Land. I said hello, DX. I said hello, DX Land. Oklahoma is rocking the mouth. Hey, Unit 12, you sounding good around the black gold, man. Keep up the good work. Hey, Unit 12, Oklahoma rocking the mouth. Yeah, I know what you're right. I'm gonna sound good. Hey, Gator, keep up the good work. Gator, Tampa Bay. Hope everything's going well for you, Mr. Gator. 9-pound hammer, Oklahoma backwoods. Keep up the good work, Gator. Oklahoma rocking the mouth. Hey, 286. I got the echo on. Hello, 286. Hello, 286. Sounding good around Oklahoma. Hey, you guys are sounding good out there. Keep up the good work. Delta X-Ray 1 Radio, Oklahoma, standing by for traffic. Hey, everybody, sounding good, man. Keep up the good work. Delta X-Ray 1, the voice of Oklahoma, out here standing by. Right. Now I gotta clean up. Jump. I save this kind of stuff. Like this Teflon wire on things of what I just got through building. I mean, look at that damn oscilloscope, man. It's doing good. No more issues. I get all this big stuff cleaned up. I'll figure out what else I want to build here in a minute. I gotta build a power supply. We'll build a power supply. We might do that. We'll do that today. Fuck it. That's a good thing to do. Let's build a power supply. As soon as I get this cleaned up. It's an XLR, it does. Well, that's really awesome. I mean, that's fucking beautiful, man. That's what it's supposed to look like. I'll get this swept up. Dustpan in here somewhere. I just ain't found it yet. Trying to find this dustpan. I set it somewhere. Anyways, things are getting better. I'm gonna suck all this shit up. Pull it over here, the corner. Get this big shit. What in the world did I do with that? Dustpan. All right, I want to. Delta X-Ray 1, your Northeast Oklahoma, standing by for contact. Anybody copy Oklahoma? Hello to you out there around Lake Erie. Hello to you, Lake Erie, DX1. Hello to you around Fort Pierce, Florida. Sounding good in Oklahoma, man. Hello to you around Florida, DX1. Everybody's sounding good, man. Keep up the good work. You're definitely sounding good over here in Oklahoma. DX1 Radio. Fort Pierce, Florida. Operator Justin, 73s, man. Have a good one. From Justin, DX1. Here's what real technicians eat. Straight sauerkraut. Oh. That's awesome, dude. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's awesome. Oh yeah. Oh yeah. Show you just how freaking accurate all this is. Y'all remember, you were just watching. Remember what it was doing? I'll just show you. So here is the transmitter going out, going to the antenna, going through all the stuff. But here you go. Pay attention. It's pretty cool. So zoom in. Zoom in. All right, so we're going to key it up. Look at the second line from the top. Keying right at 15 to slightly over 15 watts carrier on AM. All right? Remember that number. All right? Watch this. Pay attention to this. We're going to walk right over here. We're going to grab our service line. We're going to screw it right in. We haven't changed anything on the radio. Nothing. We're going to come right over here. 50 watt scale. Forward power. And we're going to put it in average. Now, you see where that 15 mark is, right? You see where the 10 mark is on the 50 watt scale. Pay attention. You see where that goes? The exact same output as this one, as this one, and as that one. And then here is the RF sampler that I built. 1, 2, 3, 4. You want to see what they look like? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's an RF sampler. The 9-pound hammer RF sampler. Built out of a switch box. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ain't that incredible? Stuff that you can build yourself. So all that was a pace switch box. I put 2 different taps in it. One's an open air. I didn't use, like this tap here, I didn't use. I just used it to hold down my shunt board inside the copper plate. Both of those. The one over here on the right is my actual tap. It goes out. So we come out of that tap and go out, and go directly into the input. Then I have on board continuation. But the way it's designed, it's only getting a slight, tiny bit of signal sniffed off. You're going to put you as much power. You can put you 1,000 watts, 500 watts carrier in there, and it's going to sniff off just a tad bit. Once again, here's what it looks like. That's a 15 plus watt carrier. Just as clean. As you can possibly make one. Oh, Anyways, there it is working for the guys that wanted to see it working, and here it is in line. You build anything you want, guys. I just wanted y'all to see it all, how accurate everything is. It's pretty impressive. You turn all the equipment on, and none of it's affecting. Nothing's putting DC on the scope. Everything's happy. Nothing's distorted. Just works. Thanks for watching.